Hey guys, welcome back to chapter 5. In this video, we're going to talk about some properties of bonds. So the first property of bonds that we talked about was this idea of polarity. This video will be a refreshingly easy look at properties of bonds. We're going to look at bond length and bond strength. So first, we're going to talk about bond strength. So bond energy is the amount of energy required to break 1 mole of a bond. Okay. So if I wanted to break 1 mole of this chlorine bond, so a Cl2, break it down into 2 individual chlorine atoms, I would have to put in 243 kilojoules of energy. So this Kj right here is the unit kilojoules, and it's the unit we use for energy. Okay. Here we see another type of bond. So this is HCl. So HCl, hydrogen is bonded to chlorine. If I wanted to break this apart into individual hydrogen atoms, individual chlorine atoms, the amount of energy required to do that would be 431 kilojoules. So what this tells me is the bond that I have to work harder to break, the bond that is requiring more energy to rip apart, is going to be a stronger bond. So if I have to put in more energy to break it, that means it must have been a stronger bond in the first place. So this may be something that I ask you guys to do is look at 2 different bonds, giving you their bond energies. Tell me which one is the stronger one. All right, so here's a list of tables of bond energies, okay? So I'm not going to make you memorize individual bond energies, but I do want you guys to notice a trend here. So I've highlighted 3 different sets. So here we see carbon-carbon single, carbon-carbon double, carbon-carbon triple. And what I want you to notice is that as we go from single to double to triple, the bond energies go up. So what that tells me is that a triple bond is a stronger bond than a single bond. Well, that shouldn't be surprising at all. It probably is going to take more work to break apart 6 electrons than to just break apart 2. So a triple bond's a little bit is stronger than a single bond and stronger than a double bond as well. Okay. So this may be something that I would put on the test, and I would put, carbon-carbon single, carbon-carbon triple, and say which is the stronger bond, and not give you any numbers, but you should be able to know that trend. Okay. Bond length. So bond length is very closely related to bond strength. Bond length is the average length between the 2 atoms in a particular compound. So if I take the nucleus of one carbon atom, the nucleus of the other carbon atom, and I measure the distance between those 2 nuclei, that would be the bond length. And the unit here, you don't need to know, it's picometers, so it's really, really small, not surprising at all. Okay. But what I want you guys to notice here is the relationship between bond length and bond strength. So a triple bond is the strongest bond. It's also the shortest bond. Double bond in the middle gets a little bit longer. Single is the weakest and it's the longest. So think about taking a string or a rubber band, and it's, let's say, 6 inches long. You fold that string or rubber band in half. It's now a double bond, little bit harder to pull it apart, and it's now half the size, right? Now it's a 3-inch piece of string. You take it and fold it again. Now it's a triple bond, a lot harder to pull it apart, and it's going to be shorter. Now it's 1.5 inches. So bond length and bond strength are related to one another. Stronger the bond, shorter the bond, weaker the bond, longer the bond. Okay. Here we see another trend. So what we see here is all of these are attached to nitrogen. And these atoms here are all in the same family. They happen to be in the halogen family. So fluorine, chlorine, bromine, iodine, all the way down group 7. So what we see is as we move down a row, the bond length tends to go up. Well, that should make sense. Because what happens to the atoms? Yeah, they get bigger. So fluorine is the smallest. Iodine is bigger. So as we move down that family, the atoms get bigger and bigger and bigger. So adding energy levels, right? The valence electrons get further away from the nucleus. So if we're looking at the distance between the nucleus of a small nitrogen and the nucleus of a small fluorine, that would be pretty close together. And if we're looking at the nucleus of the small nitrogen and the nucleus of a big iodine, of course, those are going to be further away from each other. And we see that bond energy roughly follows suit, right? So nitrogen and fluorine is the smallest or shortest bond. It's also the strongest. Nitrogen and iodine is the biggest bond, the longest. It's also the weakest. So we still see that trend. That's pretty much it for bond length and bond strength. So the things I really want you guys to know and take home is the relationship between bond length and bond strength, kind of that inverse relationship. And then also be able to predict single, double, triple bonds. So just know that in the absence of numbers.